Well, good morning and welcome. My name is Bernie Jaroslaw. I'm the marketing manager for Whitmix, and I'd like to welcome you all to our special live Q&A on 3D printing. So this is your webinar. Instead of us talking to you, it's time for you to ask questions of us. And this is an open-ended questions about everything you wanted to know about 3D printing. And this is something that every person will participate by writing questions in your questions area, usually on the right side of your screen. And please keep them coming. We'd like to make this a comprehensive and worthwhile webinar for all of you. So please keep the questions coming, and our speaker will answer them. So first of all, if you are a CDT, this is going to be worth 1 hour towards your recertification. And that will be done by us contacting you within a day or so, and you will be able to answer a couple questions. So take some notes if you can, and those CDT certificates will be available. Will be sent to you. You'll send them into the NBC, and that's how you'll get your credit. The other thing is that this is being recorded. So if anybody hasn't seen the program in your laboratory and you'd like for them to, just go to whitmix.com and into our webinar section, and you'll find it called Open Q&A for 3D Printing. Now, our presenter today is Cory Lambertson. I bet many of you know him. I'm going to actually read his bio so I don't miss anything really important. Wouldn't want to do that to you. So let me do that. This morning I have the pleasure of introducing Cory Lambertson. Cory is our technical services representative at Whitmix. He's a certified 3-shape, Roland, and Asiya trainer. He develops and conducts CAD/CAM equipment and software training and provides technical support and assistance to our digital customers. Before joining Whitmix, Cory worked for 2 years in his father's dental laboratory, Heartland Dental Laboratory in Hillsdale, Michigan, as a 3-shape CAD/CAM technician. Cory received his Bachelor's of Science in Finance from Andrews University in Berrien Springs, Michigan. So as I said, this is your program. We'd like to have your questions answered. It is totally anonymous. We're not going to mention any names. So no matter what level of experience you have and would like to ask questions, fire away. Cory is open to all questions, and we'll be happy to answer all of them. So without further ado, Cory Lambertson.
Thank you, Bernie. I appreciate it, as always. All right, so if you have any questions, feel free to ask at any time. I'm going to go ahead and pop up the questions box, and we'll see if we have anything coming in just yet. All right. Okay. Yeah, we have one question in. It's actually on 3D printing. It says, "How often do I need to calibrate my 3D printer?" This is a unique question that's going to be dependent on what 3D printer you have, and there's different technologies for 3D printers. So if it's a vat polymerization style, so like the Asiya printers, we recommend when you start to encounter issues, let's say with like delamination from the build plate, that's a good time to recalibrate the z-axes. And also for the Asiya Maxes, they'll give you a warning saying approach failed, and that's a good time actually have to calibrate at that point in time. As general maintenance, you can do it really once a week. At the beginning of the week, it's not going to hurt it. Just like you do with your scanners. If you have a desktop scanner or an intraoral scanner, you should be calibrating those once a week at least for that. Let's see if hopefully they answer the questions. All right, I do have a question. I would like to know if there are any guidelines on putting files into Chitu before prints, specifically with auto supports. Is this something that never gets discussed? I'm guessing, is that that must be like a nesting software. I have not played with that. I've seen it on some of the other, I guess it would be like on the Anycubic page or the Frozen page. and I believe it's like a slicing software to add supports. There's no guidelines that I know of. It's going to be really specific on the material itself. So some resins actually require different support generation. It all depends on on how flexible the resin is, or really how fragile the resin is. If it's a very soft resin or a brittle resin, you're going to want to put larger supports. For that software that you're using, you know, I haven't played with that one exactly, but you know who asked the question. If you want to go ahead and contact me afterwards, we can take a look at that software together and see what options there are, and I can give you some guidelines for supports inside of that software for different different applications. So let's say surgical guides, splints, models, RPD frameworks, so on and so forth. Now, if it's a higher quality printer, let's say like an Asiya or Carbon, or even the next-gen printers, they all have support generation that is dependent on the material that you're using, and it's all automatically populated for you. Hopefully that helped answer the question. I have another question here. Is there a way for the files to go into a already printed file after, oops. Let me see here, okay. All right, is there a way for the files to go into already printed file after the job was printed? Yeah, absolutely. So there's, for like automatic population. So there's no way for it to like automatically move, at least in the Asiya software, move from the like ready to print file to a print file completed. I know exactly what you're referring to for the person that asked this. So inside a Millbox or some 3D, whenever you import an STL file from a ready to mill folder, it will automatically move to a milled completed folder. That is designed in the software. To my knowledge, the Composer software does not have that option. However, that's something that we can actually give to Asiya, and Asiya can take that information and potentially apply it in the next build of their software. So they are very responsive to the customer's requests, and that's something that I can see easily done. So let's go ahead and I will actually print out all these questions, and if there's anything here that I can implement or help implement in the Asiya Composer software, we can go ahead and add that in. Next question. Cory, when 3D printing, what is the root cause of layers being laid down in an inconsistent fashion? That is to say, why do some printers have discrepancy between layer thicknesses? Let me see if there's any more added on that. All right, layer thicknesses from time to time, and is this primary reason for distortion? So, there could be multiple things that can cause issues for inconsistent layering. One of the biggest things that can cause a layer not to be formed properly, and this is like off of thickness, is if the printer doesn't have any sort of technology to actually register that it's at the proper layer thickness. So for example, the Asiya Max has a technology called the Smart Positioning System. And what happens is the build plate moves down into the resin vat, and when it gets down to the bottom, it will actually touch off on these position encoders. And so once it reaches that proper layer thickness, it can sense that from the viscosity of the resin. It'll expose the light, separate, and then reapproach, and it does that process all over again without any sort of hesitation. Now, for other printers, for example, Formlabs, they have the base of the printer is a silicone-based material, and with that larger build plate, when it approaches into the resin vat, actually will create a pocket of resin in the bottom of it, which will then cause layer distortion. Beyond that, I've also seen layer distortion caused from the build plate shifting. So once again, this deals with the viscosity of resin. When there's a higher force from that resin, when that build plate moves down, that resin is trying to escape between the layer. And what can happen is the build plate can actually shift during the printing process, which can also cause layer distortion. Let me see if I answered that question completely. Why some printers have discrepancy layer thickness from time to time. So really it's the viscosity of resin is what causes that inconsistent fashion if they don't have a way to battle against it. All of the Asigas do. But for other printers, I would check the Z-axis. Something that I do when I walk around shows when I'm looking at 3D printers is I will actually push on the top of the Z-axis on the build plate, and I'll see if there's any flex. If there's flex on that mechanism, I already know I'm going to have layer distortion from the get-go. All right, why can some resin companies offer their materials cheaper than others if all are created equally and essentially come from the same manufacturer? Well, each material has its own chemical composition behind it. And so some raw materials cost more than they will for other materials. So for example, for a splint or a surgical guide material, all of those have to be biocompatible raw materials going into the formula, versus a model material doesn't have to be biocompatible. So the cost of that material, we can source cheaper resins or cheaper raw materials to go into that formulation for that. So for the more expensive resins, you're mostly going to be biocompatible resins. And then beyond that, for a resin to actually be deemed biocompatible, let's say if it goes through any sort of FDA qualifications, let's say it's a splint material and it wants to go through and become a 510K compliant material, there's a lot of overhead costs that goes into that. I mean, we're talking, I think it's like $50,000, $60,000, if not more, just for a resin to be validated through that total process of becoming 510K approved. So there's a lot of overhead costs that are unseen when you're buying a bottle of resin, but we have to cover those costs somehow. And that's why you see different materials or different types of materials from one manufacturer costing different prices. Will you compare and contrast features and benefits between Asiga printers and carbon printers? All right. So carbon printer is an awesome printer. They have an awesome separation technology inside of their resin vat or cassette, they call it. It's a really cool printer, but it's a really expensive printer. The main differences between the two printers are really going to come down to the separation technology that they have. Also, the speeds between the Asiga and the carbon will be a little bit faster than the Asigas. However, the Asiga is completely open source, the carbon is not. And then beyond that, you can own an Asiga versus carbon, you have to go through a subscription base. And so you'd have to pay for a yearly lease, depending on which one you go with. I think it starts, around $30,000. I don't know, since I don't work for carbon, per year, and at least a 3-year subscription. So it's for some companies, let's say if it's in an automotive industry, I could definitely see where that's feasible. In the dental industry, I find that to be a very expensive printer for those applications. The carbon printers right now, they have a larger build plate than what the Asiga Maxes do, or the Asiga current available Asiga printers. However, when Asiga at IDS, they launched what is called the Asiga Pro 4K, which has a build plate the same size as the carbon printer, but it won't be really available for purchase until later this year. We're still waiting for those to be officially released. Is there an articulator available without pins? Absolutely. So inside of 3Shape, we can actually customize the control panel for any model articulator option in Model Builder, and we can make one without pins. That is not a problem. I have another question that says, do you have any examples of these things to show? I don't know exactly what these things are to show. If you want to go ahead and describe later, we can. I can show what you were asking for the examples of. How many and which curing boxes are approved to use with the Asiga Max for complete denture resin? So if you were to refer to our the actual first denture webinar that I placed on, the first course, I actually listed all of those approved curing units. I can't think of all of them off the top of my head, I have to be honest. But if you go to our instructions of use on our webpage, it'll actually list them all. Actually, I can search that real quick, because that should only take a quick second. Let me pull it up on this computer over here. So to find this information, if you go to whitmix.com, go to products, and then under 3D printing. Under 3D printing, if you were to go to the Denko digital denture material section, I'm going to go to the instruction manual for our base material from Denko. And this should list all the curing units. So the curing units that are available, it would be Dynamax has a version, Electrolyte has a version, Honel and Uvatron. Also, I believe Drave is approved for, that was approved on the Carbon system, which is the Denko resin as well. I'm going to expand this page, just getting quite a few questions coming in. All right, let's see here. So the next question is, does using a resin from another source, a non-validated source, necessarily mean that one will not attain the desired end results of accuracy and precision? Most manufacturers strongly warn against using non-validated third-party resin. Why is this? You know, I think it's a really good question. So there's tons of resins that are available on the market. And the two things to consider when creating your resin profiles for open source 3D printers is how much the resin is going to shrink upon initial curing. And then the next actual characteristic that comes with it is how much of it is overexposed, which creates an XY growth. So when you're trying to create your own resin profile, those are the two things that are going to alter accuracy and precision. And if you don't know a known shrinkage coefficient for it, then you're not going to be able to accurately create the resin profile for that resin. So there's a list or a test that you can do. You can print a structure in different micron layer thicknesses, measure it dimensionally, and you can actually create a chart showing what that shrinkage is for that resin. We do have documentation here at Whitmix on how to do that. It's actually created by Asiya, and so if you'd like that information, let me know, and I can go ahead and send you over the full documentation on how to create your own resin profile. And it can actually be applied for more than just the Asiyas. We use it for multiple 3D printers. Next question is, do you see more denture resin being FDA approved, and if so, when? So there's, you know, the digital denture market is fairly infant at this point in time. So of course there's going to be other resins coming out. You know, and I would probably see new resins coming out at major release, like at major shows. So let's say Lab Day Chicago will probably see a release. The next IDS will probably see multiple resins that are being released for dentures. So right now we're right at the starting point. We're going to see I believe tons of resins coming out in the future. However, it's, you know, all depends on that FDA 510K approval, which once again, that is a longer process to obtain. All right. In your opinion, what Asiya printer is the best entry-level printing, specifically dentures, trays, and models? The Asiya Max has just been a workhorse. It's just been an awesome printer. It's extremely fast. It's extremely accurate. We've sold tons of them, and we've sold to multiple laboratories that have bought multiple Asiya Maxes. So honestly, the Asiya Max is the best entry-level printer. The new Pro HD and the Pro 4K essentially is just a larger Asiya Max. I haven't been able to test it firsthand because they're not actually out yet. But once we get them in, I can already see just the way that they're designed and built off of the Asiya Max. We're going to have similar results, and so those are going to be awesome printers as well. The Asiya Max has a print speed of 50 millimeters, so 5 centimeters in an hour. The new Pro printers is 4 centimeters, so 40 millimeters in an hour, which is extremely fast. But they're both, all of those printers are going to be excellent, but the Asiya Max has just been a workhorse. Plus, they lowered the price to $10,990, so it's kind of hard to beat that as well. Example related to, okay, so this goes back to the question is, do you have any examples of these things to show examples related to problems with outcomes, i.e. incorrect layering? I do not have any examples right here in front of me. I do have another webinar that I did that was 3D printing tips, tricks, and hacks. And if you go to that webinar towards the end, I cover errors and issues and how to overcome them. And some of those actually show layering issues. If you were to go to different shows and look at different printers, if you were to look at that first couple millimeters on the bottom of the model, if you're going to see like it looks a little wavy, those are perfect examples of where the layering did not come true or were not a true layer thickness when printing, or even if you see delamination as well. Let's see here. So I have another question. It says, Bill Reyes seems to love his Asiya and is very active key opinion leader for a number of companies. Is his experience unique to his workflow processing, or can one experience a similar outcome? Why is this the case? So yeah, his experience isn't any different than any customer that purchases an Asiya Max. The Asiya Max is an awesome printer. The Asiya itself is an awesome company, and it partnered with an awesome company, Wibmix. We do an excellent job in helping our customers succeed. So the success that you're seeing with Bill Reyes, you're going to see at your own laboratory as well, because you're going to have an awesome team backing you. I mean, what he's doing is awesome. He's also an excellent technician, and he understands the technology, and he takes the time to understand the technology. So if you take the time to understand the technology, you're going to have similar results. I mean, it's an awesome printer. And if anybody was to go to the Asiya Dental Experts Facebook user page, you're going to see that it's just not him having awesome results, but it's widespread. Almost every technician or every user is having awesome results with their printer. That's a killer printer. So I have another question. What would it take to get my 3D Systems curing box approved for Denko resins? You know, that's a great question. I don't know if it ever would be, but that would be up to Denko themselves directly to validate the next end curing box for the Denko resins. So that would be completely on Denko themselves. So if you contact them, they'll be able to let you know if it's going to be down the pipeline or if it's something they're thinking about in the future. Is there a webinar or is this a webinar or just questions and answers? Bernie, you look great.
Yikes.
Best to you and Janet. What is the approximate? This may be two questions in one. Oh yeah, this is two questions in one. Sorry. Is this webinar just a question and answer? This is just question and answer. It's literally titled Q&A 3D printing. So it's questions from users and answers from me. There's no actual like PowerPoint presentation or anything like that. Okay, now this goes to Bernie. You look great. What is approximate post-processing time with your model resin products and also your printed denture materials? In other words, how much time does it take to post-process, clean up a model versus a denture versus a, sorry, text box ran out, versus a splint, night guard, etc. All right, so a 3D printed model, we're looking at 10 minutes in an ultrasonic cleaner, and that's 5 minutes in 2 different alcohol baths, and then 5 minutes of light cure. So, I mean, 15 minutes of total time. Let's give it, 20 minutes from scraping off the build plate to letting it air dry before putting it in that the actual light cure chamber. The Denko resins, the post-processing and cleaning is the same in the alcohol. However, you do have to do 20 minutes, a total of 10 minutes on each side in our Uvatron curing unit. That is the fastest curing unit available in the Denko denture system. And so you're looking at a half-hour total post-processing just for the curing and cleaning. For a denture itself, the digital dentures, you can spend a lot more than just a half hour. And the reason why is because, let's say if you wanted to add characterization, let's say I had some of the annex gum from Annex Dent and I wanted to characterize that denture or add some stain to it or a glaze to it, or let's say if I was to polish it using traditional methods, then you're looking more than a half hour. You could be spending an hour or 2 hours per denture. But that's depending on where you call the finishing point. But just cleaning it and curing a denture, you're looking at a half hour of time. And then splint night guards, you're looking, we're coming out with the splint material. It's not out just yet. We're awfully close. I don't have the exact cure time on that. Bernie, do you happen to know what that cure time is?
I don't, I'll find out.
Okay, Bernie's going to find out for our splint, our night guard material. However, it's all going to be dependent on that the manufacturer's requirements for post-processing. Some of them may take a little bit longer, depending on the chemical composition and what curing unit they recommend to use. All right, Bernie's going to go check on the splint to find out exactly. Another question, where and what is the best way to learn all the different applications for use with the 3D printers? What would the cost be? Really the best way to learn of all the different applications for use with 3D printers. So if you're just getting in the market for looking at 3D printers to purchase, I would highly recommend take your time, do your research. There are some key characteristics that I look for when looking at different 3D printers. The first thing is it open source? And when I say open source, I mean, can it use resin from other manufacturers? The next thing I look at is the XY accuracy of it. So I want a lower number there. Z resolution would be the third thing I'm going to look at. And then really after that, I'm going to look at the support side. Who is the company that's selling it? Who's the manufacturer of the company? Try calling the support technicians and see if you get somebody to answer. Ask them questions, see if they can answer it in a educated format. See if they're fumbling around for the answer, or see if they know it immediately. And then really from there, the best way to learn about 3D printers, I mean, there's so many people that offer courses, different prosthodontists that offer courses, different doctors that charge a lot of money for these courses to learn about 3D printers. And I kind of find those courses actually be kind of biased towards one printer than the next. So I would highly recommend, really, if you have opportunity to do any sort of like lunch and learn with a company, or have a sales rep come in and show a printer, or even come to a facility and sit down with a technician and learn about the printer and actually print some models that you have, and see the complete workflow, that'd be the best way. But of course, that's always in a perfect world. If you can't do that, send some samples to different 3D printer companies, have them print for you, get the results back, and see if it's meeting your expectations. That's what I would go with, how to see what one is giving you the best offering. And the cost for learning about 3D printers, I mean, if you were to come to any large lab meeting, there's going to be a dozen presentations on 3D printers, and those are all going to be fairly inexpensive, if not free. Or you can watch tons of webinars. Sherry Weatherby has a webinar on what 3D printer is best for you, and she actually lays out different brands and different printers and what to look for. And it's actually a very descriptive webinar that's not biased. I highly recommend viewing that webinar, and it's free to you. Let's see here. What is the approximate learning curve, and how much time does it take to become comfortable with the Asiya digital workflow? Are there courses taught in Louisville or elsewhere? Absolutely. So the 3D printers, they honestly don't take that long to learn. So the average learning curve that we see on our Asiya 3D printers is about, if they've never touched 3D printing before in their entire life, you're looking at about a 1 month learning curve. That's about how long it is. And that's at the longer end of it. We've seen some users, first-time 3D printer users, pick up that 3D printer, and they have that learning curve done and over with in a week and a half, but they also print it every day and learn from it. But I mean, the learning curve is not just going to be dependent on the technology. It's also going to be dependent on the person itself. And then when you purchase a 3D printer from Whitmix, you get a 2-hour training course that comes with that printer itself. We're going to guide you through setting up the printer and starting your first print, guiding through all the different topics in the software itself. And then we do a follow-up call afterwards. So we want to make sure that that first print went well. And then we want to make sure that if you have any questions about the printer, how do we answer it? Can we answer it for you? And what, if you had any issues, what were the issues? How do we overcome it? So far, we haven't had any issues after initial setup. But we do have general questions like, hey, I was looking at the multi-stacking feature. How do I multi-stack? So then we'll just run through that again with the customer. And once again, it doesn't cost us anything, cost you anything to give us a call if you need support, help on your printer. So give us a call if you have questions as well.
I will let you know that the curing time on the split material was only validated for us on the auto flash, which was about 10 minutes.
Okay.
It's most likely about the same in the Methacrylate, but it hasn't been validated.
Okay, so
Officially, but
we validated our split material with the auto flash curing unit from NK Optics, and that is a total curing time of 10 minutes. So cleaning in curing time, 10 minutes total, so we're looking at probably 15 minutes, including scraping it off, letting it air dry. And we are going to get it validated in the Uvatron, and that's expected to be around that 10-minute range as well for curing. So can you tell me more about the importance of using certified curing unit to cure the Denko resin or digital denture? Yeah, so you have to use an approved curing unit that's approved by Denko when using their denture resin. And the reason why is because if you do not, it's not under that 510K umbrella, and you very well could not be doing the final surface cure, depleting the active monomers on that external surface. So you have to follow that process according to the instructions of use from Denko. If you fall outside of that, you no longer have a biocompatible device. It is not 510K approved. It is not a validated structure at that point in time. So you do have to follow and use the approved curing units according to Denko. All right. What is the approximate cost per model, quad and full arch, including technology acquisition costs? That is to say, what is the fully burdened cost to print a quad and a full arch, including hardware, labor, post-processing, resin, curings, liquids, etc.? I actually do not know that number. That would be a great question for Chris Fry, our sales rep. I know the actual models themselves. I just looked it up for Asiya has a new feature which does a cost analysis for a quadrant. I believe it was like $1.50 just in material itself, and for a for a full arch it was about $3, which is fairly inexpensive. Actually, I think it was actually less than that. For the person that asked that question, let me know. Actually, give Chris Fry a call, and Chris will be able to. Yeah, or yeah, you can email him at cfrye@whitmix.com. Yep, that's CFRYE@whitmix.com. He can answer that exact question for you. I don't have that. I handle the technical side, unfortunately not the sales side. Will Whitmix do a test model print for a customer? Absolutely. The answer is yes. We can print for any person out there. So if you have a sample model that you want to be printed, just give us a call. We'll give you the direct means of how to have us print it for you. And so for that, the best way, I believe, is to contact your dedicated sales rep first, just so we can have you in the books, so you're being recorded as a potential sale or a potential customer that's interested in it, so that we can, and actually the sales rep will stay on track of getting you that sample as well. And then beyond that, from there we'll send it out. Usually it takes about 3 to 4 days to get it back to you in hand. Has the issue with separating resin models from PMMA that may be applied over a resin 3D model? I don't really understand the question. I think was the question has an issue with separating resin models from PMMA. Okay, that may be applied over a resin model. I think it questions like how maybe separating like a acrylic, maybe like a salt and pepper technique to a printed model. Has the issue been resolved? There's a company that has a patent out on that exact process. So unfortunately, we don't have an exact, there's no exact method or material that can be like officially sold for that. However, I have heard of users using petroleum jelly on the models as using that as a separating agent. I have a question. Hey, could you walk me through how to download the software? Absolutely. This is a customer that purchased a 3D printer. Give me a call. Call the tech number 1-800-626-5651, extension 1437. Any of our techs can walk you through on how to install the software. It's as simple as downloading it and then selecting next through the prompts, and it's super simple. You can get the latest version of the software from asiga.com. And if you go to asiga.com, you'll log into your account. Under the account page, you'll be able to view exactly where to, sorry, you'll go to, I'm trying to think of it, you'll go to My Products, and then you'll see Software. You'll select on Software, and then you'll find an actual link to download the latest version. After you download it, just go ahead and run it through the steps. Next, it's not a question, it's a comment. I like your t-shirt. This is the Asiga Dental Experts t-shirt. You can get one of these, but you have to have a 3D printer. Every once in a while, or you have to have an Asiga 3D printer, and they actually come directly from Asiga themselves. So you'd have to contact them to see if they have any available. That's who I got my shirt from, but I do like the shirt as well. What is the smallest layer thickness one can print? Is there a layer thickness that determines the degree of detail, fidelity in any given die or model? So for the Asiga 3D printers, they can go down to 1 micron layers. And the reason why they can achieve that, how they can achieve that, is due to the fact that they use a servo motor instead of a stepper motor to control the z-axis. So it gives a force feedback, which allows it to properly create that layer. Now, printing an object in 1 micron layers would take forever. I mean, it would be there for a year. Well, maybe not a year, but forever. And it just wouldn't be worth the time. Is there a layer thickness that determines the degree of detail? What is like the cutoff point on that? Really, anything that I've seen below 25 microns, you really don't see much of a difference. I mean, we're splitting hairs at that point. I've printed some objects in 10 microns, and it was like, I mean, it was super smooth, and it looked amazing. However, there's that trade-off of time that it took to print that, and for me, if I'm in a production laboratory, it's not worth the time to spend printing a model for, let's say, if it took 6 hours at 10 micron layers. To me, that's not worth it. When you could print something that's just as accurate, may not have the amount of surface detail that the 10 micron would, or may not look as smooth in 50 microns, and have it done in an hour. I would prefer to print it in an hour. But really below 25 microns, I can't see a difference under the human eye. Sorry, I just joined. I might be asking a question that's already been asked. Can you briefly discuss the various digital denture design software capabilities with Asiga, and do you have observations about them that you can share? So I have there's a full webinar that covers, it's actually the digital denture program number 2 that covers how to design the software inside of 3Shape, and then how to nest the denture inside of Asiga, the composer software. So can you briefly discuss the various digital denture design software capabilities or compatibilities with Asiga? So there's multiple design softwares that are available that you could use with the Asiga. I mean, there's, ExoCAD has a denture design software. 3Shape has a denture design software. Denko has their own denture design software or denture design service that you can use. And then Full Contour has a denture design service that you can use. let's see, Blue Sky Bio has a denture design software that you can use. So realistically, it needs to be able to export out a STL file. And under that STL file, that's what you would need to have for compatibility with the Asiya Composer software. Hopefully that answers that question. If you have other questions, you can just email me directly, or if you want to give me a call. You can email me at productsupport@whitmix.com, or if you'd like to see a demo of that design software, you can actually watch that second webinar, the digital denture part 2. Is there a rule of thumb of the length of build time versus film thickness, layer thickness, or is this ultimately determined by project height of the print job? Is there a rule of thumb for the length of the build time versus layer thickness? I mean, there's no rule of thumb. I mean, if you're printing something in thinner layers, it's going to take longer to create the object versus you're printing something in thicker layers, it'll take less time to create the object. But this is, once again, all determined on the actual, like you said, the project or the height of the build. The printers themselves, like different technologies, are going to print at different speeds. So, for example, if you're using stereolithography laser, that uses a laser to draw the object, like the Formlabs printer. If I was to print the exact same model and the exact same layer height with an Asiya printer, or layer thickness at the exact same height, it's going to print a lot faster on the Asiya than it would the Formlabs, and the reason why is because the Asiya exposes the full layer all at once versus the Formlabs exposes just a section of it and draws the structure on. So there's really no rule of thumb, but there is, like if I'm printing, let's say if I'm printing models for fixed prosthetics, let's say if it's a crown and bridge model or an implant model, I'm going to print that at least 50 micron layers or less. If it is a study model, orthodontic model, I'm going to print that at 50 micron layers or larger. So I can get away with 100 micron layers and still have an accurate structure that is accurate enough for the application I'm applying it for. Let's see here. Question, how portable is this printer? I work for a university and we do have clinics in very remote areas in northern Canada. I'd like to be able to go to these clinics and use the printer for the time we're there to treat patients. That's a great question. Actually, the Asiya Max it's a very portable printer. If you're going to use it for that structure, I would go ahead and get an actual dedicated carrying case for it. The printer itself actually runs off of 12 volts. It's a 12-volt system. So you can literally run it off of a car battery if you wanted to, if it would last that long. So it's not a very demanding printer for, I guess, electrical requirements. But absolutely, you could definitely take this printer across the country if you wanted to and print at different locations. That's not a problem at all. Just make sure if you do use a printer for that, in a Asiya Max specifically, or any printer, you're going to want to recalibrate that Z-axis anytime you move it. So if I move it from this bench over to the bench over here, just in this room, I need to recalibrate the printer, and that goes across the board for all 3D printers and also desktop scanners as well, and milling machines. Do you happen to have a comparable chart which illustrates the approximate cost difference between milled and printed denture? I do not have that. I know it is significantly less to print a denture than it is to mill a denture. I know Sherry Weatherby had a chart that she actually received from Denko showing the different forms of manufacturing a denture and the costs associated with them. But the 3D printed denture is the most cost effective. And the reason why is because you can, I don't know the exact, do you know what the cost of a puck is for milling a denture?
Well, a denture, no, but I'm going to find out the cost differential in a second.
Okay, Bernie's going to get that for us if he can. But we're looking at, $10, $15 to 3D print a full denture, which is really inexpensive. Let's see here. While Bernie's getting that, what is the FDA approved time for use in the mouth as it pertains for the Asiya and Whitmix denture resins, splint resins, etc.? If it is over 1 year, how do we get around this fact when selling a long-term restoration. So the denture resins is 510K approved for it's a long-term restoration, a long-term device. It can be used for greater than 1 year. That's absolutely no problem at all. The restorations of these materials that are being designed for like a 510K FDA approved, they have to meet the wear requirements of the traditional device. So for example, if when Denko got started, their 3D printed denture resin had to be comparable to an acrylic denture that was made in a traditional method. And so it had to have the same lifespan, it had to have the same wear requirements, and so it has to meet those requirements before even getting or being approved for a 510K. Same goes with the splint materials as well. So it has to be just like a traditional splint that you're going to make in a traditional method or analog method. It has to be able to meet those same wear and life longevity requirements. So the fact, or how do we get around this fact when selling a long-term restoration? I mean, it can be used for over a year. There's nothing. I guess I don't understand how do we get around it when selling a long-term. There's recording of Denko using the denture resin in different patients for upwards to 2 to 3 years since the beginning. So they have dentures, some of the first denture resins still being actively used or still being used by a patient today from when they first started with their 510K.
Cost differential?
Yeah.
Approximately, depending on the size of the denture, the actual cost, material cost and printing is about $18 or $19.
Okay.
As opposed to a disc, which could be $60, $70 or more.
Okay.
So.
Okay, so a disc itself, you're looking at $60, $70 plus for the disc of material. For a puck to mill out a denture base, and a total denture 3D printed as a denture and teeth, they're looking at about $18 to $19. So still under $20
yes,
for that full denture. So that's you're looking at a third of the cost from milling it. Plus, you're not tying up your mill for milling that denture. You're looking at, I think, 3, 4, 5, 6 hours to mill that at least, depending on the milling strategy and what mill you have, versus when you can print a full build-plated dentures, let's say 3 or 4 or 5 dentures all at once in an hour and a half. So you can print 5 times the amount of dentures than you can milling in half the time. Or you can print 5 dentures in half the time that it takes to mill 1 single denture in a mill. So any intel on resin clearance for full dentures in Canada? Denko, I believe, is working on that. So that is a project they're working on for use in Canada and other countries. So I don't know actual clearance because, once again, I don't work for Denko themselves directly, but they are working on that classification to be able to sell that in Canada as well. So it's coming down the pipeline, absolutely. It looks like we're caught up on the questions. These are all very good questions. Really had to think on a couple of these. So this has been a lot of fun. I don't know if Bernie's looking for anything else. Nope. Will 3D printing and more information on digital dentures be featured at the 2019 Digital Excellence Forum I heard Wimix is putting on? Absolutely. Are there seats available? I would imagine so. Yeah, there are still some seats available. If you do want to go ahead and get some seat, or if you want to come to the digital forum this year, definitely contact us as soon as you can, just because it will sell out. And then who do I contact to get registered for that program? We have a lovely lady named Sharon Britt. She would be the best person to contact on that. She's going to give all information. She has a list of all the speakers, who all will be here, and what they're speaking on. When and where, it's actually located here in Louisville, Kentucky. Bernie, what are the exact dates on that?
Sorry.
The exact dates for the Digital Excellence Program?
July.
Sorry, we're getting that for you. Can Bernie get me box seats at the 2020 Kentucky Derby? That's a good question. That's something I have to take up with Bernie. It's
25th and 26th.
The digital excellence. That's the denture program. The denture, we have a digital denture program that's the 25th and 26th.
Oh, you're talking about the
I said a market, what?
October one.
Yeah.
That's October 4th and 5th.
Okay, so the digital excellence, so our digital forum is on October 4th and 5th. That's located here in Louisville, Kentucky. Do you have a?
Yeah. See some of the.
Oh, you have a list of everybody.
Yeah.
Oh, okay, cool. So we'll have Dr. Ed McLaren there, Bennett Napier, Mark Williamson, Savan Polarian, Alf Lastry, Bart Hyde, Dr. Brandon Stapleton, Mike Webb, Reed Nunley, Nick Winlow, Gary Morgan, yours truly, and then Evan Kemper, which also works here at Whitmix. So that's a great lineup. We'll also have sponsors. So NOAC will be there, 3Shape, Roland, Silcox, Ascentium, Smile Shapers, Smile Line, GC America, Sim Systems, Preet. We'll also have the podcast, Voices from the Bench will be there, and the PTC program will be there as well.
Here's the programs.
Oh, okay. And there's a full list of programs. Can they find this on our website?
Yes.
Okay.
Please do.
So you can find a full list describing every program that we're going to have here. I will be speaking on digital denture design and manufacturing with Mark Williamson. It's going to be a great program. We're super pumped for this year. It's going to be at a different location. Usually it's at Whitmix. We're actually going to have it off-site, and the reason why is because we're running out of space here to house everybody. It's getting so popular. I have another question. Ivoclar and other milled denture manufacturers state that their 510K is for 1 year only. Are printed resin dentures all greater than 1 year? From Denko, yes, it's great. It's rated for greater than 1 year. This is as it pertains to dentures. How is the resin different than PMMA? That we cannot disclose because I don't manufacture the resin. That would be Denko, and most likely Denko is not going to give you any sort of formula for the resin itself. That was a good question. They do have the actual the formulation is going to be different. The wear characteristics are going to be comparable. PMMA is obviously stronger as if you were to do like a flexural strength, but it has to meet the same wear characteristics as a traditional denture. Its principle, in principle, is polymethyl methacrylate, different than a resin. No, it is a resin. I mean, it's methyl methacrylate. Methyl methacrylate is the base for the Denko resin. It's just missing the poly part. So, another good question. That'd be a good question for Denko though on that. Cool. Yeah, I think that's all caught up on the questions themselves. This was a lot of fun.
Would they like to see more of these live ones?
Yeah, I guess if you guys want to see more, we can do literally just about any topic here at Whitmix. So if we can do milling, we can do question and answers on 3Shape. We could even do any of our core product line too.
Yeah, sure.
Yeah, that'd be fun.
Like the idea of it.
Yeah.
Okay.
So, and they would love to see more of these. So, cool.
Cory, great job as always. Thank you all for attending, and just want to remind you that we have about a 24 to 48-hour period before this will be up on the Whitmix webinar site. So just go to whitmix.com. There's something at the top that says webinars. Click on that, and you'll be able to see that. And one reminder for those of you who are CDTs, it's about a 24-hour time frame, and we will send you the a test actually, and you'll take that digitally, and as soon as that's sent back, we issue a certificate which you'll send to the NBC, and they will send you your 1 hour credit. So I want to thank you all for joining us. It's been a really great time. Cory did a great job as always, and we look forward to seeing you at a future Whitmix webinar.
So before we close it off, I do have a couple questions that popped up.
More questions. Okay.
So where to go? How do we obtain our CDT credits?
Oh, I just said that.
Oh, you did? I'm sorry.
Yeah.
Shows
They'll
how
be
well.
notified.
Shows how well I was paying attention.
They'll be notified within 24 hours or so.
And then, do we have any courses on ExoCAD? We do not have any courses on ExoCAD. We are strictly a 3Shape dealer. But yeah, it looks like that concludes it. Awesome. So thank you guys. Appreciate your time. If you have any other questions, feel free to give us a shout out. You can contact me at productsupport@witmix.com, or you can give us a call at any time. Phone number 1-800-626-5651. And if you need the tech department, it's extension 1437. Thank you. Have a great day.